expand everything out, right? It seemed kind of annoying, but the reason why I had you do that so you could get a feel for what exponents mean. I'm not going to ask you to keep doing that. You always can, though. If you get stuck on like a complicated problem and you're not sure what the rule is, you can always just expand it and do the math from there. So this is the most basic form, the x to the 7th. But here on part B, notice that there's two different bases, right? So we have xy squared times x to the 5th y squared. What you do in this case is you're doing the math on the bases that match. Like, if you're just looking at the x's, you just add the x exponents, the powers. Like, we know that's a 1, so we add those for x. And then for the y part, you keep the base y, and you just add the y exponents. And you get x to the 6th, y to the 4th. And we talked about that on Friday. What's the name of this rule? Find it on your paper. What is it called? Product. What does product mean? No. Multiplying. What's being multiplied here? The bases. They have this. We're multiplying the bases. They're the same. That means you add the exponents. Okay? And that was the first thing we did Friday. Look at your second page from Friday's packet. Look at the rule you came up with then and see how it compares to this one. This from our notes today. Did you come up with something like that? Right? So, and what's this rule called? Quotient. Quotient means we're dividing. And so this says if you're dividing, you subtract the exponents. But there's kind of a special circumstance here. That was, and we had, even on Friday, we had a few different kinds of examples. There's one where, and you might want to make a note of this somewhere. This first example A is when there's more, or I should say, the power is bigger on top in the numerator. And this example on the bottom is for when the power is bigger in the denominator, or in the bottom. And so it's basically saying wherever the larger exponent is, you leave the variable there, you leave the base there, and you do the subtraction there. So here it's x to the 5th, x to the 5 minus 3. But in part B, when the exponent's bigger on bottom, you do the math on the bottom. You do the subtraction there, and you leave a 1 on top. And what's really happening there is everything is canceling out. So some students will forget to leave this 1 here, but here's what's really going on. And we explored this Friday. You have 2 A's on top, 3 on bottom. You cancel. There's 1 A left on top, or on the bottom, sorry. But on the top, it looks like there's nothing left, but we wouldn't write a 0. Because what we're really doing here, A divided by A is really 1, and this A divided by A is really 1. So we really have 1 times 1 left. And that's why there's this 1 here in the numerator. Okay. And this is the last thing I'm going to talk to you about before I let you work on your own. The third rule, this one we explored Friday as well, but it's got a second one that sort of piggybacks on it. This is power to a power right here. Yes, where you multiply the exponents. And then the second one is power of a product. Okay, and that's the second one right here. And this is the first one. So on Friday, when we were trying to come up with the rule ourselves by doing the expanding everything, we figured out that if you have a power on the inside and a power on the outside, you just multiply those two together. But this one over here, the blue one, it's similar. It's just there's two things going on the inside. It's kind of like a distributive property for powers. The power on the outside goes to this base and this base. So it becomes a to the n and b to the m times n. And there's an example right here. There's 3 more rules in your packet. And the reason why I'm not going over them directly today is, one, it'd be really boring. You might already be bored out of your mind right now. To like go over that kind of tedious information in one long lesson is a lot. But 2, the reason why I'm not going to go over it like that is because I really want you to sort of look at the formulas, try and do them yourself, and sort of struggle with them a little bit. Because it goes in your brain better if you do that work instead of me doing the work for you up here. So what I've got for you is the keys to each page in your packet are around the room. You are welcome to, I know how y'all feel about moving around, so if you need to take pictures and just sit at your desk, like that's fine. But brain research says that the getting up and moving around is good for your concentration and your memory. But you don't have to. So here's my plan for you for today. I want you to explore each exponent rule by reading the rule and examples. You have 3 new ones that we didn't talk about on Friday, right? So you're going to be exploring them on your own. Try a few of the easy problems on each page, like the first row of problems, for example, and then check your answers with the keys posted around the room. If you did all right, try the next few problems. They get a little bit harder as you go down the page before you move on to the next rule. So your goal is to complete the packet before you leave here today. Tomorrow we're going to have an activity to do, and I'm assuming when you come in that you went through all these rules, you asked me if you needed help, and you're ready to go when we get in here tomorrow. So while I say I want you to work on your own, I don't mean don't ask me questions. I just mean don't ask me questions until you're good and stuck, all right? Because I want you to sort of try something. Go see if you got the right answer. Look at the key. Try and figure out where your mistake was. And if you really cannot do it, you come bother me at my desk, okay? So it's not 100% all on your own. Just try it on your own for a bit. And you may have your music while you work. Any questions?